Welcome to the 1D NMR Workflow demonstration on Galaxy. This is brought to you by Phenomenal Project, funded by European Commission Horizon 2020 program. To use the Galaxy workflow, you need to first register, create an account, and log in. Please refer to our documentation and other tutorials on how to create an account and log in into Galaxy. In this video, we are using a development instance, but the same steps can be repeated in a new deployed Phenomenal Cloud research environment on Amazon Web Services, Google Cloud, or OpenStack. Once you logged in into Galaxy instance, we will now show you how to load an existing workflow. For this, go to the Shared Data at the top, click on Shared Data, and on Shared Data, click on Workflows. You will see now a set of workflows for different type of metabolomics analysis already there for you. Click on the NMR workflow and then choose the import option. This will import the data to your local environment and local space. Once the data has been imported, a green bar appears. In the green bar, click on Start using this workflow. You can now see the data, the workflow imported to your workflows. Click on it and choose the Edit option right at the top. This will load the workflow into your local canvas, which you are able to see different steps of this workflow. You can navigate using the blue rectangle at the bottom. Now we will go through each step of this module. The first step is a data importer. Click on Data Importer. This will import data from MetaboLights, which is a repository for metabolomic experiments, directly into your local Galaxy environment. You need to know the correct accession number for the NMR data to be able to import the correct data from MetaboLights into Galaxy. This workflow only works with 1D NMR data. Also, please note, NMR has to be in certain structure and certain file format to be able to be uploaded into the Galaxy workflow or to be used by the Galaxy workflow. For more information, refer to our wiki on this section. Once you enter the right accession number, this data will be automatically loaded into the Galaxy workflow. Next step, we will convert the data into an open access format known as NMR/ML. There are several different options that you can choose from vendor format drop-down menu, and then choose the right vendor format that the data is to be able to convert that into the open access NMR/ML. In this example, you're going to choose Bruker. Please note the multi-thread lines going from one module to the next. This shows that you are using collections of files for each steps. Using collection of files enable us to take advantage of parallelization steps within Galaxy. Next step, you're going to convert the files into a single zip file, as a single zip file is the source of input for the subsequent step that processes the data. This step can change in the next iteration of the workflows. Once the data is zipped into a single file, the single zip file will be passed on into next module, which is our NMR 1D. This is the main engine of pre-processing data. These steps process or pre-process the NMR raw files and converts them from time domain data into frequency domain data by applying certain steps. These steps are driven by a macro or a set of commands which tells which parameters and which steps should be taken for data to be processed, from raw data to process frequency data. These steps include Fourier transformation, zero filling, line broadening, phase correction, baseline correction, and alignment of data. For more information about how to set up the macro, an example of macros, please refer to our wiki on this section about NMR. Once the data has been processed, it will pass on to the final step of this module, which is plotting the results. The data will be passed on in this step, and you can see PDF output of the data and how they looked, how they're aligned, and different aspects of data sets. For next video, we will show you how to run this workflow. Thank you for watching.